In this video, we will look into the multi-threading, and the target audience for this video are software engineers. For beginners, software engineers who are just starting out and have gained hands-on experience with basic programming concepts in Java and other languages. And for experienced professional senior engineers looking to strengthen their multi-threading concepts to excel in interviews and work efficiently across technologies requiring multi-threading expertise, blah blah blah. This looks something which everyone tries to understand when they read these things. And the technologies, lot of technologies, they use these concepts, multi-threading concepts like Java, C, C++, Go, and many more languages. And single-threaded and multi-threaded systems, if you look into it, many technologies rely on single-threaded execution for simplicity, while others leverage a combination of single-threaded and multi-threaded paradigms to achieve concurrency and scalability. I think this sentence can be like the programmers who have a deep understanding of multiple languages, they should be able to get this sentence very easily. What does this means, this sentence? So let's discuss, we will discuss in details how these programming languages utilize these concepts to achieve the goals. So before diving into multi-threading, let us understand what's the difference between process and a thread. So this is very important thing. We need to understand how machines work internally. So a process is any program loaded into memory from storage and is the fundamental unit of execution. Let's add some visual aid to this sentence. This is my CPU, my laptop. In my laptop I have a CPU, and disk and RAM, and in my disk there are files stored, right? OS files are stored, other programs, right? For example, Notepad. These files are stored, and when you start your machine, OS is loaded into memory, operating system files are loaded into memory, and this runs as a process inside your machine. And if you start the Notepad application as well, this is also loaded as another process. So inside the process we have threads. So this is the overall idea of process, so that we understand difference between the process and the thread. Now let's look into the threads. So threads are internal to process. So for example, if we have a process, take an example of any process, right? This is a Notepad process, right? In Notepad we have UI and the file which we are working with, right? This is loaded into RAM, and the file which is loaded into RAM, the changes comes from UI, and this is stored on the disk in the backend. So this is a thread 1 which is making changes to making changes to files in the RAM, and there is another thread P2 which is storing the details into the disk. So these details are stored, like two different threads are working together to achieve this task for Notepad. So this is the threads. So what exactly thread in the process looks like? So if this is a process, right, every thread will have a stack and instruction pointer. So combine these two things we call as a thread. Along with the thread, there are a lot of other things loaded into the process. This is our process. So code is loaded, and there is a heap also assigned to each process, and there are a lot of other things. Frankly speaking, I don't know what exactly all other things will be loaded along the process, but these are the core things. As a software engineer, we need to understand how multi-threading works under hood. So now let's directly jump onto the Java program, how it works internally in the memory. So for example, we have this Java program here. So let's look how it works. So as soon as the JVM, right? These are, if this is a JVM, these are the JVM files, and these are loaded into memory, RAM, and we have CPU here. So as soon as the JVM is loaded into the memory, it takes some space here, it takes the space here. In that, it creates main thread. So what exactly main thread consists of? Main thread is the combination of two things, as we mentioned here, right? A stack thread will have a stack and instruction pointers. In the same manner, JVM also creates a stack and instruction pointer. instruction pointer, and these two combined called as a main thread. And we have heap, this is the shared memory, and we have code as well. Apart from that, many other things will be loaded. So let's see how this program, this main program, this simple one-line program works in the JVM. So as soon as this JVM starts, it looks for the main class and then the main method. As soon as it finds this main method, it loads onto the stack this method, and this method which is loaded onto the stack all are stack frames. They are called as stack frames. This is loaded here, and it is giving an instruction to print hello world on the hello world. So this will be printed to the console here. So this will be printed to the console. It's an IO instruction. So basically the instruction goes to IO console to print the hello world from main thread. So in this manner, a single thread, main thread, executes the application. So if we have other classes in our main thread path, so all those are executed by main thread only. So when is the new thread created? When we write the code which says new thread, in this scenario a new thread will be created and a task will be handed over to that thread for execution. So let's understand how this works in JVM. So as I said, it is for the beginners as well as seniors. So some of the audience who are listening, looking into the video, they might know this, but still I want to cover for those who are new to Java and also want to solidify their understanding of multi-threading, how it works inside JVM, right? For example, we have thread 1, main thread T1, this is main thread, and as soon as this instruction is given to JVM, it creates one more thread with the instruction pointer. Every thread will have instruction pointer and a stack and the heap which is shared here. So when this line is executed, a stack is created and this function is added to this stack here. And this is an instruction to the console, IO instruction to the console to print hello world from separate thread, and this executes, and in the console we see this hello world. Right? In the console we see hello world from separate thread. Hello world from separate thread. So in this manner, for each new thread instruction given to the JVM, it creates a stack and executes the instructions on this stack using this stack and instruction pointer. So this is the beginning, it's the starting point of multi-threading. So for now we will stop here, and in the upcoming videos we will try to go more deep into these concepts.